Good morning, guys.
Hello.
Oh,
Um, Let me have a quick update from my side. Last week I was attending the CLDB summit, and I think I was asking the CLDB guys regarding to how they are profiling and debugging, but their their answer is that they are using how regarding how they are profiling. They are using the building metric and trace point for profiling their for profiling CellDB. And regarding profiling, we are in SIF we are using multiple ways. For example, using Linux perf and some Homebrew tools, and also using graph for sure. But when it comes to CDB or Seastor, the the continuations is posted to the reactor, and it's difficult to have a decent backtrace when looking at when you are looking at the profile. So they don't neither does CDB has some tools to can which can visualize such a kind of backtrace, because the continuations has a signature like, let me post in the chat, like full bar lambda, something like this. So we will have some ways to parse the signature like this for better backtrace. And guess that's all I have when for Sista or CellDB debugging. And another interesting thing is that I also attended a RockDB meetup. It's a once per year. The meetup happens. It held every once per year. So it's a good opportunity to learn from other guys working on RocksDB. An interesting things that a a company is working on enabling RocksDB to run in along with fiber or coroutine. So that's I believe that's what we are after, or we are quite missing in our project. But I'm still contacting the its others to get more details regarding to how they resolve the problem of the RocksDB, because RocksDB is built on blocking semantics of POSIX threads and POSIX synchronized primitives. And aside from it, I don't have much to update. Currently, I'm reviewing Inxing's and Redux PR. I'm trying to understand to translate Redux change shortcut, shortcut path to Seastar. and that's I'm posting the Redux PR's link in the chat. Yes, that's all I have. And regarding to TrimMaze PR, I'm still running through a Redux test suite, so it's very close. That's me, I guess.
So RocksDB will use Seastor to
Now,
implement coroutine.
The ultimate goal is to implement fully async implementation of our object storage. But as you know that RocksDB is based on POSIX thread, so that's why we are our short-term plan is to put BlueStore and RocksDB into the alien territory.
Okay.
That's a short-term plan. But when I learned that another company has achieved have made it happen, that they rebuild RocksDB with async fiber. That's very encouraging. So I thought it might be possible to implement the underlying to implement the primitive using fibers.
Is that C++?
Yes. Yes.
Features? The standard library?
I think they are using. Let me post the link for you guys. It's just hold on. It's just very short talk regarding to this area, but you can understand the basic idea of it. It's a talk on fibers / coroutine and async write API for RocksDB.
Hi, Kefu. What's the profiling tools they used? The name. I didn't catch up the name.
Profiling.
Yeah, for Seastor.
You talked with StellarDB guys. What the profiling tools they
yes.
use? Can you tell the name?
It's they're using tracepoint and metrics.
Tracepoint metrics, I see.
The building features. The tracepoint is pretty much the timestamp stamped on each when the request is the transit a new status, so they can understand how long it takes for each phase of a request. That's basically what we have in OP tracker, right? And regarding metrics, that's a building feature in Seastor metric group. The counterpart is I guess is performance counter in SIF. And an interesting thing, aside from that, an interesting approach is that they are using some technique like sampler. For example, they have a sample ratio. Like if the sample ratio is like 5%, like 5 out of 100 requests is sampled, and so the 5 out of 100 requests will be stamped with will have a very detailed timestamp in their life cycle.
They implement their own sampling
In
right?
SelDB.
They don't use third party.
No.
Okay.
Their SelDB is a NoSQL DB, so they can use some SQL clause to query the performance metrics of a query or a request. That's very, very interesting. But it does not apply to Ceph, I guess.
Yeah. So what do you mean to use Lambda to debugging?
Oh, it's actually it's not for debugging, it's for profiling, because as you know that each lambda in created in a function has its signature, and its signature encodes the enclosing functions.
Okay.
So with which we can understand which function created this lambda closure. It's better than nothing.
Okay.
Even we don't have a backtrace, because it's a continuation posted to reactor, and it's not living on a stack created in its caller. We don't have a backtrace.
When some error happened, they will print out the function to create the lambda function. And for the debug, I think we can use just the int3 to create a breakpoint in the lambda.
Could you say it again? What we can use to create the
interrupt 3, something like you plug in some sample code, just cause the interrupt 3, and then they will stop there. So then you can do
it's something like dtrace or strace. Could you post the name in chat?
I will. Such operation like this, you can just plug in the code into the lambda function. Then
that's a software interruption. I see. Okay,
yeah,
I see.
it will stop there, and then you can use the next step to step by step in the lambda function.
Sure, thank you.
Still, the naming. Well, I'm thinking now about the proposed implementation of the proposed translation of rich shortcut to Seastor world. And in such situation, I guess we would have plenty of lambdas in the same function. So even having a backtrace would be, well, maybe half of the win, because the second part will be a need for deciphering that very long symbol names with arbitrary named lambdas, like lambda number 1 in function do-op, lambda number 2 in function do-op, etc., etc. So maybe have those guys tried to use a functor, basically a class with overloaded operator.
Mm-hmm.
Just thinking loudly, trying to find some kind of named lambdas to have more descriptive symbol names in backtrace.
Yes, that's one way to encode the name to have final control of the signature name. Yes, I think Yinxin's approach is it's a little bit closer to what you are thinking, because both V2 design the currently refractory of messenger refractory, and Yinxin's approach is to rename to have a named status of to have different name for different state of messenger.
Okay.
Yes, but I get your point. But it's
On the other side, this operator is extremely hard for grabbing when it comes to
yes,
grabbing.
yeah, and it's difficult to the overhead is for developer is relatively high, because we need to come up
Yeah.
with a name whenever we want to create a chain. To even what most trivial thing, we need to create a name just for profiling. But it's a good approach, because most time we could embed create a function for which returns a future for profiling for high level
Okay,
functions.
I see. So instead of going with extensive usage of instead of putting our logic directly into lambdas, we are using some kind of intermediary function, intermediary method, just to acquire meaningful naming. Is
Yes,
that correct?
yes, yes. For
Perfect.
low level, for some trivial things, I think we need to go with the anonymous lambda. But for some mid level, high level functions, probably we need to have a named functions for encapsulating the or to abstract the underlying logic, both for maintenance and for profiling. I think it's a good way
Sure,
to go. Yeah.
that sounds good. I was a bit afraid about debugging. Well, about the situation when somebody fills a ticket on tracker saying, "Hello guys, you have a crash.
Yes.
There is
Yes.
a backtrace," and well,
Yes.
going with plenty of anonymous lambdas would be just hell for developers. But this approach, I mean, the one you proposed, work perfectly.
Also, Riddle, I'm not sure you have played with the tool named address to line. Not the generic Linux address to line, but the homebrew tools comes along with Seastor. Yinxin has been using it. Me also.
ADDR
Yeah,
to line. I
Address,
saw
ADDR
it's
to
used by perf when doing annotate, and but I haven't used it by hand at the moment. ADDR to line. Yep, this one, this guy.
yeah, because
It's
whenever
internally used in perf.
it could be used for perf. It can also be used for debugging, and I think in future, I guess it could be helpful for our bug reporting when we move over to OSD, because it will decipher the backtrace where only have encrypted name or address, but no human readable names.
Cool. So the developer will just check out a proper commit, then use file names and line numbers.
Yeah,
Perfect.
And probably we need to ship address to line or embedded it, so the bug reporting or the crash report will be less occurred. Even we don't have the exact commit or the binary for bug or debug symbol for running address to line. Our user could run on behalf of us, even they are not aware of that they are using address to line. But that's a long-term goal.
I guess we will need to have that users will need to have debug packages with debug info shipped in. Is it compliant with our current policy? Should we will need to change it?
You mean
I mean,
what kind of policy?
Are we providing stripped binaries in our packages currently?
Could you say again? Packet what?
Our packages with Ceph we are providing to customers? Do they have debug symbols already stripped?
Oh, really? Actually, we do ship debug symbols.
Okay.
Along with the pre-built packages, and you might know that. Interesting fact is that our debug symbol of for RPM is like over one gigabytes.
C++.
True, and a lot of symbols are not shared. And last time you are embedded a safe comment into OSD. That's increased the size of debug symbols. I'm not blaming you, but that's a fact, and we need to face. But and yeah, we do have debug symbols. If the user choose to install it.
Yeah, sometimes even with address to line, for example, I have sometime met with some dangling features that was not solved when the Seastor app returned, and the Seastor just crashed without just with segment fault, and there's no lines printed. So I have to revisit all the code to see where was wrong, and finally I found that this is caused by a dangling feature.
So in that case, what we have is a segment of fault reported, but no back trace.
Yeah, no traces.
Oh.
But that's very rare. I only have that once.
Yeah. That would be a nightmare in future.
Yeah.
If our user or customer run into such a kind of a case. Anyway, let's hope for the best. I think that's all I have at this moment, and I still own you guys the driver, the main.cpp, main.cc for the OSD prototyping, and we'll also. Oh, sorry, I forgot to paste the URL of the shortcut implementation, the Seastor translation of shortcut implementation by Redoc. Crimson. By the way, Redoc, I need to, I should have asked for your opinion regarding to if we want to have your change in master.
Well, at the moment it's still I'm treating is just as a test field for
Test bed.
Yep, exactly. Thanks for correction. As test bed for Seastor.
Okay.
Well, the big for the current OSDs, the biggest benefit I see is not even performance because the increase in IOPS, the increase in performance numbers aren't satisfying to another and duplicate basically duplicate the IO path, but it was useful just to expose some other issues we have in OSD, in current OSD. It's because, well, it's profiling with simpler IO path is just easier. It turned out, for instance, there is some issues with notifying, with waking up current async messenger. In event center wake up method, we are using pipes just to communicate that messenger should process our response.
Currently, we are using pipe, right? If I recall correctly.
Yes, we are using pipes, and we can. I guess we can switch to event ifd for Linux.
Why even FD is different from pipe? Both of them are based on FD, right?
Pipes are about streams. Pipes
Oh,
are simply custom
yes.
in kernel.
Yes.
They are about streams. Event ifd was designed as exactly to communicate, to pass very small bit of information to be handled in a way that lets you handle it with equal or just the typical event loop.
Yeah, regarding the features, the pipe is more rich than is richer than that of even FD. So presumably it should be faster. Yes, we are actually. I'm using even FD for to enable the alien to talk to the to Seastor.
Good idea.
Yeah, so it should be faster.
Anyway, I started from a quite untypical setup. Just one TP OSD TP per OSD to eradicate the impact of pglog from the equation, and I'm pretty surprised because of IPC I was seeing of this single TP OSD. It was terribly bad, around 0.33. It means that each instruction on a powerful, beefy x86 core requires around 3 cycles to execute each instruction. Those machines are able to execute 4 extra instructions per cycle. And it's via sustained throughput. And well, I'm not. I can explain. I can see 2 explanations for that issue. We have pollution, right, driven by switching to kernel over and over.
The cache is being warmed up over and over again.
Sorry? Could you repeat, please? Haven't got you.
Hello?
Redoc.
Hello, can you hear me?
Yes.
Kifu, can you hear us?
Yes, I can. How are you guys?
Okay, there was some glitch, I guess.
Yes. Yes, last time I heard from you is that we have two examinations.
Yes. The first explanation would be that we are going very, very frequently kernel, so our caches, our branch predictor buffers are polluted, are invalidated very, very often. Second one is that our I/O path is just so complicated, so long that CPU has no possibilities to warm up before invalidating or before getting a lot of eviction.
Yes,
And
yes.
this could be pretty interesting, especially in the Seastor context when we are designing the number of execution stages.
Yes, dual P is pretty long, but the funny thing is that I think dual P is composed of lots of async stages. For example, the maybe blocked by things, and the
Yes.
contact
But
lookups are also async because they are if the context OBC is not in cache, we are going to locate from the on the disk.
yes, we are asking object store, sure, but
Yeah.
most of the time, at least, just take a look on the profile output. It seems that caches for object context are pretty effective.
Okay. Cool.
I haven't seen significant traffic coming to object store because of find object context. So I would rather assume we have pretty good hit ratio, or at least in the very restricted scenario I'm running.
So Redok, I think probably the first step is to have a huge dual function, just like what we have. And the second step is cut it into smaller chunks, so each of them can be fit into probably the code cache of a decent CPU, and to profile it to see if we can have them have the operations staged in batched by execution stages for better performance. But I think that's the next step. First step is the readability and the functionality and the simplicity.
Okay, but maybe we could get response much sooner than after writing this all code. I would like to profile with a very simple object store with memstore instead of bluestore. This would allow to strip the traffic going to strip the system calls for reading.
Mm-hmm.
Would allow to strip the overhead of going to kernel, and if seeing good IPC, we could try to artificially increase the complexity in memstore, just see where the threshold is located.
By threshold, you mean the push the limit to
on the complexity we get in one stage.
Mm-hmm.
But I'm not sure what's the good what is the correct way. Maybe just running with memstore without any further modifications is the way to go.
I think to play around the memory store is a good way.
If IPC is bad also there, where we have I mean in memster, where we don't have any traffic to kernel, then I would say it's just because of very, very complex and long IO path, and maybe we will need to start dividing. Maybe we will need to have the division into stages, even even at the level of high-level design.
Redo, sorry to interrupt you. What do you mean by IPC?
Instructions per cycle.
Per cycle.
I mean,
Okay, cool.
the number of instructions executed in each cycle by CPU.
What is the normal number of IPC?
For AX, well, it depends on software and CPU, of course. But in typical 80 CPU, well, those chips are able to withstand around four instructions. It's very optimistic. Well, nicely written code, we have 2 or 3 instructions per cycle.
2 or 3 of them.
Yep.
But it depends on what instruction it is. If it's a very long instructions or very time-consuming instruction, it varies, right? It depends on the instruction.
Do you mean the factors that could hurt the IPC?
No, I mean some instructions takes for example 2 cycles to execute, and some of them take even longer. Some of them are very fast, like it will take a single cycle to complete.
Of course, true.
So in general, it's like 2 or 3 instructions in a cycle.
Yep.
But if you have on a single core.
Exactly.
Okay.
But if you have even an instruction like plain math, like doing addition on memory, well, basically you are getting 2 micro operations. One is load, which can take a varying number of cycles. Second one is just plain addition with 1. Which it can be executed in 1 cycle. But those CPUs are super scalar, which means they have, for instance, multiplied execution units. You can finish you can do 4 additions in each cycle. Still, under assumption, you are able to feed the CPU with code, with data, you are able to satisfy all those dependencies.
Yes, they can be, and the core can be pipelined.
Yes. They are usually around 20 or 30 stages.
Yes, that makes sense.
So you mean we can use the IPC to measure the performance?
Well, I think so. There is
I think it's a good benchmark.
But for the certain CPU, the IPC is fixed, right?
No.
This depends on the software you're running.
IPC is fixed. Actually, theoretical maximum throughput of CPU is fixed and can be calculated.
Yeah.
But it's very unusual. It's a very optimistic scenario if your code is able to reach that theoretical IPC.
Yeah.
Usually there are some issues like waiting on memory, like mispredicted branches, like all that crazy stuff that slows you down. But still, it's much better to be around 1 or 2 instructions in each cycle instead of one instruction for 4 cycles or 3 cycles, something like that.
Yeah, it's just like a racing car. You purchase a very good racing car. It can run at for example, 400 kilometers per hour, but it can also be waiting for a red light at the crossing.
Of course.
Ideally, we want to have it running at 200 kilometers per hour.
Yep.
But even though the IPC is bigger for our Crimson, we couldn't tell the final I/O performance is better.
But I think it's a good implication of how the good index
Well,
of how our program is running. It is running at a full speed. There's no reason that the I/O is slowed down. What for example, if the CPU is burning, why and there is no I/O happening? It's just ridiculous, right? Because it's just an index. I believe a very visible index. If the CPU is running at 100%, I think it's a CPU bound, and we need to improve the CPU utilization, or it's not balanced across the core. But the upside is that one core is saturated.
Well, I think with Seastor we are trying to address very fast I/O devices, like not spinners. I mean, we are trying to address NVMe flash drives. They can provide, well, I would assume 1 million of IOPS, right? And it's if in such scenario the most limiting the most average resource is CPU power.
Is what?
Is CPU power. Is CPU,
okay, is CPU power.
Yep.
Ideally, the Crimson OSD will be a CPU bound application.
That's correct. I guess. And definitely, well, we will need to. I'm pretty sure we will need to bypass kernel, both in network and storage layers.
Yeah.
So I would assume that DPTK and SPTK or their clones, well, similar implementations, similar approaches will be typical scenario.
I agree.
I have some questions. I also sent the email to discussion, and I will share my screen. So, can you see my screen?
Yes, I can.
Okay, so here I have questions. When the client connected to the Seastor thread, and they have the connection between for example, call one and is call one, yes, call one and client one. There is connection set up, and the OSD layer found that the PG is belong to the call M, and
yes.
they will send the request to the call M, and the
Yes.
call M need to send the message to the replicated OSD. So here is the call M send to the replicated OSD, or call N has a connection with replicated OSD. So
Yes.
it's the call M or call N send the message to the replicated OSD.
I think it's a core. It will send. Actually, it's a core N who is sending the message to the replication to the replica OSD, because
So
it's
the connection is shared between the cores, right?
Connection reference is shared.
yeah.
Yes, connection reference is shared, right?
Yes.
So
Yes.
here is the call M use the connection reference and send the message to the replicated OSD. But the replicated OSD has a connection with call N, so the reply is accepted by the call N, right?
Of course.
Sure. True.
The reply accepted by the received by the call N, and the call N send the replicated OSD reply to the shared M call M.
Yes. But it's
Then
wrapped
the call.
it's wrapped by the connection layer.
Yeah.
What do you mean by connection layer?
The messenger should encapsulate the fact that the message is the connection is established on different cores.
No, the messenger has the connection, right? But the call M has the reference. So the connection is set by the call N. So which layer know this is reply to the call M? Messenger layer or OSD layer? OSD layer get that it's just a message.
I think
a new
OSD layer.
OSD
Message.
layer get the message PG ID, right?
Yeah.
Just take it as a new message.
Yes,
So
it's just a message.
Yeah,
from,
just a
message.
So OSD layer will just identify the PG belong to the call M. So the OSD layer will send it to the call M, right?
No. Message contain PG based on based the hash PG ID. So at the message layer, we can choose the call.
So message layer not identify the PG ID, right? Messenger
Yes.
don't analysis which PG it belong to. Message just get the message.
Yes.
And then send the dispatch to the OSD. OSD will identify the message content and get the PG ID. And know that it belong to the call M. They will send the message to the call M.
It's not send, it's dispatch.
Yeah, dispatch. Just the communicate and throw the message to the call M, right?
Yes.
So this chart is right. What has and the call M wait for all the message come back from the replicated OSD. All the response come back and then return to the return to the originally call one OSD.
I think it doesn't return. It just send another reply.
Another reply.
Yes.
I think OSD will offer something like get connection by a OSD ID.
Yes.
And it will return us a connection interface which offers a function named send message, and will pass a reference to the message to be sent to it, and we can then concatenate whatever continuation is
No.
is
From
to be done. Yes.
For the replicated OS response is a new message. We know it's a new message. So from for the call M, it just receive the new message, and they will check the queue if all the check the in process something or OP if all the replicated OSC replied.
What do you mean by new message? Is this a reply or something?
Yeah, it's replied by replicated OSD. Just the replicated OSD send a message to the original OSD, to the primary
Okay.
OSD. It's
Okay.
just a new message.
In that
So-
case, I think OSD is supposed to, PG is supposed to offer a primitive that encapsulates this message exchange. Then when it like OSD, then for example send push right, OSD right. I'm typing in the chat in case you can see me. It's right to peer OSD ID
You
message.
write something?
Yes, and
Get a connection.
it should be something like this: OSD right to peer OSD ID. And in the right to peer, we're supposed to consume the reply. I think. What do you think?
That means the call M, when the call after the call M get all the response from the replicated OSD, they just send something, send a message to the primary call one, right? Just trigger a new communication
there's no primary
with the
core. You mean
no,
the core which originated the request,
connection.
right?
Yes,
Yes.
have the connection. They trigger
I
a
think-
new communication.
I think it just hold a connection one reference and use that to send message to client for
So
the
you
reply.
mean that is call M send the client reply,
Yes.
not the call one.
Yes.
No.
Yeah, whoever owns the connection will be sending and receiving the message.
Yes.
No. I think call M is submit to call one to send the MOSD reply to the client. Submit to call one to reply to client. Like
So
the
call M ask call one to send the client reply.
Yeah.
Like
because the
here,
connection
what
because
what
because the
I saw here.
connection is on call one.
But you
think
said that the call M can use the connection reference to send it to the replicated OSD. So the same way, the call M can use the connection reference send the connection to the send the message to client one. Right here, you say that there's connection reference here.
I think movie snap 3 to the call N.
But they all think that call M can use the connection reference to send the message.
I think although call M has the reference of the connection to, but the send message is by the call N. Connection call M only submit to.
You think this step 3 is like this one, right? So what's the result? Who sent how to use the connection reference?
How to use the connection?
I think
I
it's
think
not that
both
complicated.
Yeah, I think both ways are correct. Because
Both ways are correct.
internally the connection 2 always send messages from call N, and the connection 1 always send messages from call 1, because they just live there, and the core M will have the connection 2 reference when it want to send a message, and in Seastor messenger it will internally submit to its original call of the connection. That's the implementation details of messenger. So I think you don't need to write that.
Yeah,
Yeah.
I think it's put it in another way, it will be taken care of by Yingxin.
Yeah, by the messenger. itself.
I just want to show the flow clearly to everybody.
Sure,
So
sure.
here you think that the call M will send the messenger to the call N, right? Then the call N messenger will send out to the replicated OSD.
Yeah, the connection on the core N will send a message.
Yeah.
So here the
Yes.
step 3 is this one, right?
Yeah.
Since the connection. So from the call M view, they use the connection reference to send out the message.
Yes.
In fact, that is messenger layer send the messenger to the call N, right?
Yes.
Okay, I see. From itself view, it think I send the message, but
Yes.
the messenger layer will send the message to the messenger will hold the connections messenger.
Yes.
Yeah.
Okay, got it. So that is this one, and
Because connection is a proprietary resource owned by shard. It's not shared.
so
When you send a message, you need to route it to the one who owns this connection.
Okay, I see. So the reference just from itself will he think that I send out the message, but in fact, the messenger layer send the message to the call with the connection.
True.
Mm-hmm.
And so can we, for example, the messenger listen on some port. So can all the messengers listen on the same port?
I think Linxing is working on it, right?
What do you mean by all the messenger listen on the same port?
Yeah.
Okay. Oh, I know. Yes, of course. Currently.
They can listen on the same port, right?
Yes.
But
and
not,
the kernel
there
will
only
distribute.
a single messenger, not multiple messengers.
Yes, only a single messenger.
Yes, a sharded messenger.
Yes.
Pardon? What do you mean the only single messenger?
A messenger is supposed to listen on a single port. There are no, for example, there are no two messengers which are listening on the same port. I think what you meant is that there are messenger, sharded messenger, listening on all cores on a single port. Is that what I mean?
Yes, all the shard service, messenger service listen on the same port, right?
Yes.
A single shard service.
Yes.
All the messenger shard service listen on the same port.
I assume that it's a plural. It's not a singular. It should be a single messenger. If you are talking about a single port.
To speak clearly, all the sharded messenger of the same messenger will listen on one port only.
On one port.
Yeah.
On one port. So you mean that they listen on so the messenger will distribute the request to the different shard?
Yes. Will accept and dispatch the socket to the different cores.
Oh, so that I see. So only one part. We only so how to say it? Listen on one part, and when we get the accept, we just distribute it to the shard, right?
Yes.
Not all the shard listen on the port, just one listen on the part.
Yes, if you are talking about the implementation of Seastor, yes, in Seastor framework, there's only one shard actually listening.
Okay, I see. And so for the OSD map, Kefu suggested we use the CS mode, right?
Yeah, I think the CS mode is probably more is simpler and better. Jianpeng, what do you think? I think it's your call.
Yeah, I think, but there is a question in this picture. In I suppose call 0 has the OSD service. So other call I think only has the newest OSD map, not the OSD map cache.
No,
They
I don't
don't.
think so. No, I don't
Why?
think so. It depends because a PG is not necessarily there's a, for example, a core. There's a core 0, core 1 and a core 2. The core 0 could be serving a request which comes like two epochs away, back to 2 epochs away, and by then it is still to serving the request. We need for example, OC map 2, and the OC and the request is still referencing OC map 2, and later on another new request comes in. It is also targets PG PG2, which is hosted by OSD shard2, and which is this new request requires the latest OSD map, and the PG is the request for filing of for serving this new request. This PG requests the newest OSD map from core 0, and it has it. So when core 0 after core 0 returns the newest OSD map, this PG now holds two OSD map references. One is for the existing request, another for the latest request. So put it another way, a PG is not necessarily holding the latest OSD map. It depends on what it depends on its history. But I agree that whenever a new OSD map from its peer OSD or from monitor is decoded, that very core is responsible for updates the core 0 with this news, and the core 0 is responsible for inform all the PGs with this news.
No, can't catch up with you. Ask a question. Go on, Jianpeng. You ask question first.
Maybe I describe is incorrect. I mean only core 0 has shared IO. The other core don't have this shared IO for OSD map.
I think so.
What do you mean shared IO?
LRU.
Shared IO, shared LRU. LRU for OSD map.
Yeah. The underlying data structure of OSD map is least recently used cache.
Okay, I understand what you mean. Thank you.
So my question here. So each PG shard core can allocate the memory for OSD map, right? They can be the owner of the OSD map memory. Like what I draw on the chart, right?
I think it might be easier if it forward the message to the message to core 0 and let it to decode it, and with some overhead of memory copy.
So you mean only the code 0 can allocate the memory for the OSD map?
That'll be easier. Otherwise, the other the other PGO cores will need to have a cache or data structure for holding a strong reference for foreign pointer.
So the memory is owned by allocated and freed by the code 0. The other shard only has the foreign pointer, right?
Yes, that's one way to implement it. What do you think, Jianpeng? I think you asked the same question before, but I didn't get a chance to reply you.
Yeah, at first, I think well allocated OSD map only code 0, but as you said, if the message from the code 1, so we must copy message from the.
Yeah.
We must copy the content from the message to the OSD map. So
that was my concern.
Yeah.
I really want to
know.
minimize the memory copy, but that complicates the implementation.
I think in ground code the handle OSD map, the interface is the message, and it considers the.
Oh, really?
It considers something like message from the OSD or monitor.
So we need to copy the OSD map instead of the message.
So each shard will allocate the memory for the OSD map.
Yeah.
Yeah, I think.
Not only the code 0, right?
That's implied by the messenger layer, because it's the messenger layer who decodes the OSD map message.
So that is what I draw here, right? Each shard has the OSD map memory, and in the code 0, we have the completely map for the epoch and the foreign pointer. The foreign pointer can point to the other core OSD map, right?
I don't think it holds a foreign pointer on. I don't think core 0 holds a foreign pointer.
But the OSD map allocated on the memory on the other cores.
Yes, that's the problem we are discussing. Either copy the OSD map or not. If we don't copy it, that will be simpler. But the downside of this solution is that we need to copy the OSD map.
We never copy.
Memory copy it.
So OS0 has the copy.
Yeah, a hard copy of it instead of a reference of the OSD map. Send it to it.
So after the code 0 has the OSD map copy, the other cores OSD map will be deleted, right?
Yes, I think so.
So Jianpeng, do you agree?
Yeah.
So
I agree with this.
Okay, so all the OS map is saved on the code 0, and here will be deleted no OSD map, and in the OSD it has a local pointer, right?
What do you mean by
no? I think
it's a shared pointer.
A shared local pointer. Okay, just shared pointer.
Shared pointer, yeah. If it's for foreign pointer, it must be local. Everything is local.
Yeah.
That's
Yeah, share the pointer.
yeah.
And
It's basically a map in the river county pointer, so it can be shared by
share
by
the
its
pointer
P
and
by other
point
shard.
to point to his OSD map, right? Each pointer pointed to the OSD map. Here needed the copy map. Copy map to the so when the call, for example, call M get the new OSD map, they will ask the call 0 to add this map. Call 0 will copy the map and add the map to his OSD, for example, epoch and shared pointer map, right?
Yeah, OSD map cache.
Yeah, OSD map cache, and then return the foreign pointer to the foreign pointer to this OSD, to the call M, right?
To the caller, yeah.
To the call M. Yeah, return when they after added the map, they return a foreign pointer to the call M, to the caller, and return foreign pointer. And the caller, I mean the call M, will add the foreign pointer in his local map, right?
Actually, I don't really think it should be maintain a map explicitly. It will just be holding a map.
What do you mean?
By holding, I mean it should be referencing the return the foreign pointer of OSD map in one of its continuation.
Yeah,
so you mean there's no local map, right?
Yeah, there will be, but will be a foreign pointer held by a PG instance.
Yeah, here you see that semi chart. There is the epoch to the foreign pointer map here.
No, there won't be a map. It will be a single latest OSD map.
Just a foreign pointer, right?
Yes.
But how they know the OSD map is the latest, or they have to compare the epoch, right?
No. It will, because
if the client send a message to it, how they know the OSD map he hold is.
It don't need to know if the OSD map is latest. It just want just to ensure that its OSD map is the new enough to serve the request. It is not necessary to be the latest one.
Yeah, how they know it is enough, new enough? They have to compare the epoch, right?
Yes.
So in the call M, there's epoch information.
No, the epoch is embedded in the OSD map.
Oh, they read from the foreign pointer. Read the epoch and from this foreign pointer OSD map.
Yes, just call the get epoch function of the OSD map and check it.
Okay, so here
compared
they
with what the message have. That's pretty much. I don't think this is not the scope of our discussion. It's actually how a PG is supposed to handle a request.
Okay, I see. So here just a foreign pointer to pointing to the OSD map is okay.
Yes.
And And if the code 0 update the map, the code 0 needn't inform the other calls, right? Wait for the other calls to request.
No. Again, I think it's not the scope of OSD map design, but it's more related to how OSD or PG is supposed to advance the OSD map. Upon committing newest OSD map, the OSD is supposed to inform all the PGs regarding to the news. There's a method named advanced PG OSD map in OSD. When the OSD commits the OSD map to disk.
Pardon, sorry. So the OSD map service will inform to the other calls, right?
Yes. But that's not the scope of our OSD map cache design.
Okay.
I don't really want to divert our discussion a lot because we have overdue for like 24 minutes.
Oh, sorry. So okay, I think I understand, and I will adjust the description here.
Thank you.
So that's all for today.
Jianpeng, do you have any question regarding to the map design?
No, I think maybe the next meeting I will push my code into the GitHub, and based on the code we can discuss.
Sounds great. I just one note. I really want to decouple the cache design with the OSD map design because for better readability and testability.
Okay.
Because you might know that Redux has noted that the LRU cache also used by the context cache, so it's not supposed to be coupled with the OSD map. It should be supposed to be the general purpose cache, LRU cache.
Yep. At the moment we have well, I wouldn't bind the OSD map with object context because well, there are only two users of the shared LRU. I'm aware about. So if we need to apply very different policies, to a policy that is very. If we want to apply a policy to OSD map handling that is very different from the policy we want to apply to object context handling, well, it's not a big issue because we could decouple those things. Yes.
Yeah, ideally we can have two different LRU. One is sharded, another is not sharded, right? The sharded one is used by OSD map, and the non-sharded one is used by object context, which is not supposed to be shared by across core.
Yeah.
Exactly.
Okay, so ideally the design should cater for both of these use cases. Jianpeng, is that clear?
Yeah. Okay, I got it.
Thank you. So both of them are very critical to our performance. For the first one, OSD map is not very critical, but the object context is very critical. Okay, so Really good. I think your next step is to come up with shortcut path of replica right.
I mean, do you mean writes over replicated backend? Yep.
Yeah. So I
Okay,
will
got it.
I will try to understand if I if my say I'm posting the URL in the chat. I will try to understand if the Seastor port of your read path makes sense, because I'm not sure if we can continue on with what is left if our request is blocked by for example by unreadable things or by scrub. The worst case is we need to put it to queue and do all the dance to do the check again. But the best case
Yes,
is that
and I guess that's what we currently do in OSD. If
yeah
we are blocked, we are just putting the object request reference to some kind of container, usually list or something like that, and return to it when some certain condition is met, like getting data from other replica.
yeah. So once the condition is fulfilled, we in current implementation we just put the OP back to the queue and rerun it through the dual OP.
Yep,
So
I think so. That's the way.
That's the safest way. But I want to understand if we can continue with what is left, or we cannot, or it's too risky to do so. Just like what I put in the
I
chart.
see.
But it looks like better, right? Anyway, mostly stylish. Another thing is that I need to finish the main.cc and that's guess, and continue follow up with the async RocksDB, because they have replied me that they will get back to me in two days also. So what how about you? I know I still owe you a review in your sharded implementation prototyping.
No problem. Just focus on the interfaces, I think, and the unit test is a good example to. I think it's a good example to show how to dispatch messengers and create sessions locally to the shard.
Also, I learned from Sage and Ricardo that their short-term plan is to have overwire encryption and Kerberos ready in Nautilus. So before we have the in shape, we are not likely have a multiple session or multiple entity support.
Okay.
So I think probably you could just follow their step and get a V2 design ready sooner or than later.
Okay.
Because we can, because the original plan is to wait until all the V2 is ready, but I don't think that's the case.
Please. So you mean that we need to follow their implementations?
Yeah, keep up with them.
Okay.
Instead of waiting for all the features is in place, because that will be take longer.
But we still need to refactor first to split the V1 implementations.
Okay.
Yes.
I just want to emphasize that
Okay.
we might want to focus on the general structure instead of the low level design. But
Okay.
yeah. Okay. So are we good? Any further questions? Okay.
No from me.
See you guys, and have a good night, and have a good day, guys.
Thank
Thanks.
you.
Same for you.
See you.
Thank you. Goodbye.
See you next week.
Bye.
Later.